My name's Heather Williams. I work for Vigily, which is a SaaS analytics company that's founded with AI, and our mission is to help create a clean energy future by empowering customers with insights. I've been in the utility space for about 20 years and had the opportunity to work with a lot of leading providers in the area and engage with over 100 utilities to help them define their consumer engagement and program strategies.
Thank you, Heather. We'll move to Per. Per, would you like to introduce yourself, please?
Yeah, good afternoon, good morning, depending on where you are. My name is Apoorv Bhargava, and I'm the co-founder and CEO of LeafGrid. I actually worked with Heather previously at Opower, so I don't think that I don't know how much we overlapped a ton there, but I've also been working in the utilities and energy space my entire career. And LeafGrid is really focused on kind of thinking about the intersection of transportation and energy, and with a specific core focus about how electrification of transport affects the grid and how we can sort of solve a lot of the systems challenges that occur as more and more people start driving electric. Been very fortunate to be growing the company quickly, and we're sort of on a bit of an uptick, and we're currently actually in close conversations with Duke Energy and awaiting some of the regulatory approvals to come through as part of the programs that were talked about previously. But yeah, happy to share more about that later. Thanks.
Thank you, Per. Next will be Dick Johnson. Dick Johnson, would you like to introduce yourself, please?
Sure. I'm Dick Johnson. I'm with a company called Nuvve. I recently joined the company, but I have a background in vehicle-to-grid technology that was developed at the University of Delaware. So I'm pretty much into alt fuel, but particularly into electric vehicles. Back in 2009, I worked with Willett Kempton on converting vehicles over to V2G, where we did a demonstration project. And then I worked with BMW and Willett and the university on a project where we actually worked with PJM also as a partner and did vehicle to grid pilot and demonstration projects that actually worked, and we gained about $113 per vehicle. So got an extensive background there, and I'm pretty excited about talking about Nuvve and their program actually to extend the V2G opportunity for other places.
Thank you, Dick Johnson. Appreciate it. So next we'll move to Quentin Demo from Europe. I believe he's still in a call, a client call. So he's going to join us for his main presentation section. I'll go ahead and introduce him right now. So Quentin is an associate partner in the Energy and Environment team of the Paris office of SIA Partners. He's been working with SIA for about 12 years in various projects, mostly energy supply and energy regulation. He's led the efforts in the area of electric mobility for about 3 years, among other things. He was also involved in designing a strategic roadmap for a charge point operator subsidiary for a large French utility. He supported the selection of vendors and materials for standard smart charging solutions. He's currently working for the French government on the challenges of accelerating the deployment of publicly accessible VSEs. Okay. Fascinating. So next, we will move to, so for the audience, if you can please go to www.menti.com and use the code 8654519 as displayed on the screen to answer this polling question, please. Are present incentives sufficient to drive passenger EV adoption to all socioeconomic levels? Is charging infrastructure properly distributed to serve all socioeconomic groups?
Stan or Jacob may want to unmute and give us a little narrative as we, I mean, it's a pretty strong opinion here.
Yeah, the opinion is spot on with what we see to be reality on the ground. So it's a well opinionated crowd.
Well, it's a well-informed crowd also, Stan. I think everyone recognizes that EVs with their price point and the locale of charging infrastructure and that is weighted more toward the people who can afford higher end vehicles right now, and we've got to get over that.
And there's there are two efforts underway that are not directly addressing, but helping to address. And one is looking at corridor EV charger deployment to connect, all cities, and some of that charging infrastructure winds up in rural areas, some of which are, low to moderate income and minority concentrated communities. And then the second is what we're working on with the DOE, David, and that's resilience planning and the need for EV charging to be adequate for evacuation routes.
Yep.
Also getting some charging infrastructure deployed in areas that haven't had it to date.
Okay, the next question is current charging technology appropriate for service to the emerging commercial EV fleets? We'll give it another 30 seconds here for the audience to respond. And again, we appreciate everyone's participation in these polling questions.
Khalil, I think this one's revealing because people are saying, haven't thought about commercial fleets. We don't know.
Yeah, this could definitely drive some of the conversations with our panelists. Okay. And then the last question. Do the rules need to change for increased EV adoption?
Well, that was quick.
Pretty obvious sentiment right there. Okay. 4 more seconds. Right. Well, we appreciate everyone's participation. Now we're gonna move, go back to our panelists, and we'll start with Heather Williams.
Thank you for inviting me to speak on Vigili's behalf today. Vigili, as I mentioned before, is an AI-powered SaaS company. We were founded in 2011 in Silicon Valley. And really, our core competencies are around utility energy analytics powered by AI. We have 17 patented algorithms around that AI, and converging that with utility consumer engagement. So making sure that customers are empowered to control their home energy costs by having data-driven insights. So that's who we are as an organization. And specifically, one way in which we apply our AI and our algorithms to utility use cases is, of course, around electric vehicles, which is a growing market. The Super Bowl this last weekend, I'm sure some of you had an opportunity to check out some of the ads. My personal favorite was sort of this mainstream discussion around EVs, which Will Ferrell very comically made a point of explaining that Norway is the top country in the world leading the charge on EVs. In 2020, just under 75% of their vehicle sales for residential customers were electric vehicles, and they have just over 15% of the cars on the road are electric vehicles. By comparison, the United States is below 2%. So it really did a great job of demonstrating that the time for EV growth has landed here in the States. And they very elegantly at the end injected, sort of to Stan's point earlier, that there are a lot of new models and options coming on the road. The ad was hosted by GM, and they've committed to having 30 new EVs come online in the very near future, which increases customer choice. And of course, that was accompanied by GM recently announcing that they're going to do away with their light passenger, fuel-powered cars from gas and diesel. So it's a really exciting time to be focusing on EVs. And along with that comes, a lot of questions that arrive in the market. We as consumers, whether we're being asked to twirl funny looking light bulbs into our ceilings, or we're trying to figure out how, a hybrid car works when we are trying to push a button instead of turn a key. We as consumers all have a lot of questions around sort of how this market transformation will happen as it relates to EVs. And so, we all sort of crowdsource our information, or we go to familiar sources to get our questions answered. And so the scale is heavily tipped away from the utilities as a reliable source of information and towards, more traditional car related sources of information. So, gas companies, Amazon, where we do our shopping, Google answers, I think, most everybody's questions on a daily basis, and of course the car manufacturers. But consumers aren't necessarily thinking about going to their utility as their trusted advisor. And in addition, they're also not thinking about framing their questions in a way that is reflective of their relationship with the utility. So that is a really unfortunate consequence, because of course the utility ends up with the burden. They're kind of left holding the bag when a customer gets an unexpectedly high bill. They of course call the utility call center. The utility has increased operational costs. They may have some branding issues or some customer satisfaction issues, and that doesn't even begin to touch sort of the grid planning and operational side of what all of those EVs coming on the grid are doing from a load planning perspective. So it's really important for utilities to sort of look at this shift and this momentum in EVs that we know has arrived, and think about how they're going to solve for this. So this is really where Bidgely's focused on helping utilities solve their EV challenges. And the core components to a comprehensive EV strategy really includes these 4 elements. Utilities can't come in and be overly restrictive about when customers can charge, or where they can charge, or which vehicles they're going to interface with, or brands of chargers and so forth. And in addition, hardware-based solutions are really not a scalable or cost-effective investment for the utility. So they really need to look at how to make their solution future-proof. And then, over the last 15, 20 years, utilities have really invested heavily in creating robust AMI infrastructures. And of course, they're continuing to invest into the future. But it's an opportunity really to leverage those investments to unlock some really powerful insights that can help inform their EV strategies and help them sort of create more optimal experiences overall. So the challenge of sort of creating the appropriate pathway for the utility to sort of sit at the intersection of that relationship that a customer has with their electric vehicle is really what Vidgely is focused on. So the customer buys a vehicle, and that's sort of a one-time transactional purchase. Of course, they'll probably make payments over time. Not many of us get to go just put a chunk of cash down and be done with it. But that decision to buy that vehicle is sort of a one-time purchase decision. But the relationship that the consumer has on an ongoing basis with their utility is a monthly engagement. There's a monthly transaction that happens for customers to be able to look at how their EV charging has impacted their utility bill. And so we really want to position utilities to be the bridge between the consumer's vehicle and their questions. So we really want them to think about, instead of just, what vehicle should I buy, we want them to start thinking about how will this impact my bill, what sort of programs are available, what time of day should I be charging, sort of more from a utility-focused perspective. So the utility really has opportunities here to create this ongoing, delightful engagement for their EV customers. So in order for there to be this sort of comprehensive strategy, there's really a couple of key components in what I'll call the early stage of the game here. Utilities need to think about how they're going to support the EV adoption, right? Just having a goal of getting EVs on the road isn't sufficient. So understanding who they can target and how they can make that shopping experience more seamless and more integrated with the utilities customer experience is really important. Being able to generate insights, understanding what EVs are on your grid, not being locked into sort of DMV data that might be sort of held away for periods of time and not come through in a super targeted and timely fashion has been a traditional pain point. And helping understand what sort of charging behaviors the customers that are on the grid with their EVs are having will help empower the utility to sort of create the ongoing engagement with the consumer. So that last piece is really how do you continue to engage EV owners over time so that you have this ongoing relationship where customers are well informed about the appropriate rates and programs. They understand how, when they charge their vehicle day in and day out, that impacts their bill. And it creates more of an empowered solution for the customers and a positive reaction towards the utility. So the planning part is one thing to create this sort of comprehensive strategy as a utility. The more complicated, of course, is executing on that. So the most critical piece of an EV strategy is for a utility to be able to do load disaggregation. So technology that will take a consumer's overall energy consumption over a period of time and be able to tell that customer exactly how much energy was spent on each individual end use. So in the case of electric vehicles, exactly how much electricity was dedicated to the electric vehicle consumption on any given day. And it's really important that that technology be, an automated, leverage automated algorithms, that it not require hardware. The future really is in the level 2 and level 3 charging. Level 1 is definitely not the future of where the EV industry is headed. And it can't burden the customer with providing a lot of input in order for the utility to be able to run their program. So really this disaggregation technology is the fundamental component to the EV strategy. As an example of what that means, kind of at a just, call it table stakes, the minimum thing that a utility needs to be able to provide a customer to empower them with knowledge is to be able to show that disaggregation in the context of their bill in sort of a proactive and automated way, so that the consumer understands on a monthly basis where those dollars went. And then, of course, you want to couple that with whatever sort of relevant programs and offers or next best interaction a utility customer might take in order to optimize their EV engagement over time. And so as an example, Duke Energy has certainly been the hot topic in the Carolina region, but they of course have an ambitious goal, as was previously stated in North Carolina, of having 80,000 EVs on the road by 2025. And that's quite a substantive increase from the number that are currently, known to be on the road. So as Duke is thinking about how do we go from 800, I was excited to numbers 24,000. So clearly there's been some growth. But what sort of incentives are required? Georgia found $5,000 was effective, but did it need to be $5,000? Would $3,000 have worked? What really is required to overcome this this goal in order to achieve this goal? So the other key piece we need to keep in mind here is that this creates an opportunity for customers to be able to help manage the load at scale by being able to use their vehicles, for the batteries to have sort of the vehicle to grid interaction for stored electricity over time. And it's Duke's position that TOU rates aren't enough, and we tend to agree. So in the sort of walk before you run scenario, Duke has engaged with Bidgely in one of their other jurisdictions to sort of formalize and put into practice this sort of digital engagement strategy for their EV customers. And the way that works is essentially, we ingest the AMI data. We're able to then identify exactly who is charging electric vehicles. So down to the customer level, who has an electric vehicle, we can create personalized insights to accompany that outreach that the utility wants to do to help market and recruit customers into their programs. And then once customers are in the program, we can make sure that they become aware when they are charging on peak. We can provide them with reminders about incentives and how their charging behaviors are impacting their ability to receive those incentives. Certainly giving them pats on the back when they are charging off peak as expected. And then, ultimately you want to be able to verify that the program design as laid out has had the intended consequence of shifting the load and making sure that the charging behaviors are in line with what's optimal for the utility. So in practice, just some examples of what some of the communications look like here. On the left is an EV adoption email. And so for a particular customer, we are able to calculate how much they would save in fuel costs. I think at the beginning, David mentioned that he's saving somewhere north of $1,000 a year in his fuel costs. In this particular example, this customer was expected to save about $600 a year. So that really helps customers that haven't yet purchased an EV, follow through on maybe exploring more about why they might want to adopt an electric vehicle. The middle insight is sort of a monthly ongoing communication that goes out to customers that's sort of driven by program logic, how many sort of strikes a customer may receive is sort of up to the utility's program design. In this example, it was 4 strikes of on-peak charging in a particular month before there's no incentive offered. So that's sort of a proactive communication they get to let them know how they're doing on a monthly basis and keep that program sort of top of mind. And then on the right, you see sort of how customers get communications when they charge on peak. So this is their sort of slap on the wrist kind of communication, making sure that they know that they charge during on peak. And then finally, you just need to be able to provide a link from those communications to help customers be able to dig deeper and understand where maybe they went awry, and help them understand sort of how their specific communications are translating to their actual charging. So this sort of portal is a one-click login that helps them sort of see, based on the intensity of the color, how they were charging, and has sort of hover capabilities to help them see really easily when on and off peak happen. So that's just kind of a high-level overview of one instance of how Visually has been engaging with Duke and other utilities in supporting their EV strategies.
Thank you, Heather, for that great presentation. So I think we do have some questions in the audience. Chat real quick. So, question from Lisa: as battery costs come down, the financial, that's actually a response to George. Anyway, I can actually go ahead and ask a question. So tell us how Visually supports the utility EV strategies. If you can actually tell us like a concise answer. Yeah.
Sure. So it really starts with what the utilities' goals are, and sort of where their pain points are. Every utility has different capabilities. So the Visually AI is really intended to augment the capabilities that the utility already have in their data science team. And then similarly, the customer engagement, the outreach and communications is really, again, meant to sort of augment what the utility might already be capable of doing. So it begins with, requirements and design, and ends with measurement and ensuring that the outreach has the intended impact.
And based on your expertise, how long does it take to launch an EV program powered by?
Sure. So the most critical element is the data feed. So once we get AMI data, which the algorithms can run on 60-minute data as the minimum granularity, then it takes anywhere between 2 to 4 months. Generally, 3 months is about our average.
And if you can tell us from your company's perspective, can Visually support utility grid edge management strategies like distributed energy resources, for example?
Yeah, so Visually understands that sort of the consumer engagement piece isn't where the EV strategy ends. Certainly, being able to manage the vehicles as DER resources is important, and so we partner with Energy Hub and Itron in order to provide those grid edge capabilities to help with ongoing grid management.
So I do have a question in terms of grid modernization projects. Those projects will be in high demand over the next 10 years to support adding charging stations, throughout multiple U.S. cities, obviously. So what major issues should city planners and infrastructure owners be on the lookout for over the next 5 to 10 years?
That's a great question. I mean, I think one of the biggest challenges right now that we are seeing is that there are a lot of different stakeholders who are coming into these working groups and so forth, and trying to figure out what programs should be designed, how we should deploy infrastructure. And I think that's a great way to do it. The key thing is it's all about deployment. This is a chicken and egg problem. People will continue to buy EVs. The people who can continue to buy EVs are the ones who can have access to charging at home. If we want to actually enable large-scale electrification, we have to basically talk to the VSE manufacturers, the ESP providers, the utilities, the automakers, and the drivers. And we have to basically understand those 5 stakeholders and ensure that we are putting as much steel on the ground for charging. But also, like just to be a little controversial here, or to perhaps just push on this point, it's not just about putting steel on the ground. And I think that's one of the problems that we have made to date, is we just say, well, if I just build a box, magically people will buy EVs. Like, that doesn't work that way, right? At the end of the day, you have to build the charging infrastructure and you have to maintain it. Because if you just build chargers and then they go out of use because utilization on public charging networks is generally below 15%, and then nobody is repairing them when they go down, then guess what? No one's actually going to go buy an EV. And so, you know, you don't want to create charging deserts, essentially. And I think if you're a planner, that's what you should be thinking about. How do we create enough infrastructure that is reliable and maintained by the right set of stakeholders who actually care about about that reliability, and hence creating the necessary infrastructure to tackle this chicken and egg problem. I don't know that answered your question entirely clear.
It does. And I guess in terms of other connecting objects other than EV, right? Other than electric vehicles. So like, how could, city planners, plan for that, when it comes to the, specific grid upgrades that they need to do? Because obviously there's going to be more objects connected to the grid somehow, or interacting with the grid somehow. So,
yeah.
So we, obviously we can't just think of EVs. We have to be able to be mindful of other connectors, right?
That's totally right. And I think I might change the framework as not city planners, but utility planners. And I think both of them have to work very closely together, of course. But at the end of the day, the reliability and the maintenance of the grid comes down to the utility. And it is the utility's job to keep the lights on. And so as we think about this influx of all these connected devices, I think what it does is it creates planning challenges, understandably planning challenges for utilities. And the more and more that these devices, and I'm sure Nuvei will share more about this, the more and more that these devices can become two-way power, it creates, I think, not just planning challenges, but operational challenges. And so we do need to move to, I think, a new paradigm of thinking around distribution planning and operations. And I think the more that we can turn that into a continuous improvement approach and a continuous integration approach, where we're taking data, actually leveraging it, making better decisions, testing, iterating, a way of thinking that I think is starting to come into a lot more utilities and even cities. I think that's what enables us to become agile as this evolution happens. There was a great line that I heard from one of our utility customers who said, "We're linear planners, and we're about to get hit with the biggest exponential change of our history, which is electrification." And so I think just having that mindset and being aware of that is going to be so important.
And in terms of some of the just looking at one of the questions on the chat, in terms of wireless charging, do you see that built into roads, parking lots? How do you see that?
I will say I have not engaged with any wireless charging companies to date who have actually built anything at scale. So I can't honestly tell you. I think it would be, sorry, I clearly don't hide my opinions, but I think there's a lot of good opportunity around wireless charging in parking lots for sure. Roads, I'm a little more skeptical of, just because, like, let's face it, the technology might work well in roads, but the right-of-way issues and all these other things come into play. And so I think parking lots are probably a lot easier.
Sure. We'll go ahead and let me ask you the last question before we move to the next panelist in the chat. So how are you going to deal with technological obsolescence for EV charging as you deploy the infrastructure?
I mean, I think this is one of the big reasons that we view the EV as the most important technological device and not the charging infrastructure, right? As far as we're concerned, infrastructure is infrastructure, and like you can try and make that as intelligent as you want, but ultimately the key sort of device that we care about is the vehicle itself. And I think part of it is just that we're now at a point, the vehicle and to Heather's point, the AMI, I mean, there's just so much more of a data-rich environment that we live in, whether it's cell phone data that gives you a sense of like traffic patterns, or EV data that gives you a sense of just like the state of charge, or AMI data that enables you to understand, that's AMI smart meter data that enables you to understand, what the load profiles look like. All of these different data streams just ultimately can feed into models that can help make forecasting, predictions, and then eventually, of course, management much more robust. And so I think what you do is you try not to worry about the pole, this pole in the ground or the wire in the ground. You try to make that resilient for the future, plan ahead, and then you let the technology kind of come in and replace it on an as needs basis, rather than kind of trying to future proof the technology today. Basically build for the future in the infrastructure side, and then let the technology come and keep happening.
Thank you we appreciate your time and great presentation. Please stay with us as we may have more questions at the end.
Yeah, of course.
Addressed to all the panelists. So next we're going to move to Dick Johnson. Dick Johnson, you ready?
Well, thanks for having me. We're in a slightly different area, as you can see. One of the areas that's the hot area right now is school buses, but also the other thing is we're working with truck companies like Lion Electric and also Volvo, moving forward with trash trucks and everything else. So it's an open market right now. The problem that I'm running into is the price of acquisition is fairly high. So Nuvi's been around for a while. We actually licensed the technology from the University of Delaware back 10 years ago. We started out actually more in Denmark with our V2G project because it was more user-friendly. They were more open to vehicle-to-grid than the United States was, and they were really set up for that. So we've been operating in Denmark for 4 years. We have corporate investors, which are EDF Renewable Energy in France and Toyota. So right now we've got about 10,000 EVs in aggregation in the Netherlands. We've had 4 years of commercial fleet V2G in Denmark, which is the longest running. So we're into 13 countries right now. So if you look at the timeline, originally Professor Kempton at the University of Delaware was basically, I kind of look at him as the father of vehicle-to-grid. So he started that, and I got involved with him in 2009 on the project that he was doing where we converted gasoline vehicles over to electric. So I was working for a company then where we did the conversions for him, and also we did conversions with BMW so that they were vehicle-to-grid ready. And so we did pilots then. Nuvi came in later and actually licensed the technology. So now our focus is on school buses. Basically, what we're selling is a platform. We've got a software program that integrates the bus or the truck. We've got an EV charger, which is level 3 right now. And I think one of the key things that people forget is you need a software program in order to aggregate the vehicles together and integrate into the grid and work with the grid operator. And we've successfully done that with a number of utilities, PJM's being the first one that we worked with. So we don't manufacture hardware. We actually partner with people to supply us with a bi-directional charger, and it has an internet capability so we can link the vehicles all together. So how does it work? I mean, the revenues from the energy market, in Denmark, we're selecting which one we want to buy each day. So we're looking at where we can make the most money. And then we're looking at optimizing the energy flow and setting it up. Now, we're looking at this in the United States with buses and electric vehicles more towards financing the vehicle using the V2G revenues. So when you look at it, we've got 3 school buses there. They're connected to a DC fast charger. And the information on those buses goes up into our aggregation platform and then connects to the grid. So we're basically looking at scheduling the bus. So the one thing our software does is allow the driver or the fleet operator to actually schedule the bus and then open it up for our vehicle to grid during the hours that it's not being used. Of course, school buses are ideal. The other place that would be ideal is the post office. So it is active both in the heat and the winter, so you can actively do vehicle to grid. We are involved in a level 2 charger, which is 80 amps, and also a fast charger, which is 60 kilowatts. And basically the bus connects with a bidirectional charger, and we're able to do onboard and look at the utility intercept. So this is one that we just installed in Illinois, so it is real. There's one, you can see the snow on the ground. That's in Williamsfield and Pekin, Illinois. So when you're looking at it, one of the key aspects I think that we have is that you have a software package that actually allows you to look at the aggregation of your vehicles. And you can also, it interfaces with the grid, so you can see where the grid demand is, and you can see how much energy the actively is pulling out of the vehicles at the time that it's doing vehicle to grid and pulling it back in. So you actually have that. And that can be managed by the driver on a mobile app that we have, so that he can actually, or she can actually plan that they have a full charge at 7 o'clock in the morning or whatever time they're going to be using it. I can tell you a story. When we were first doing this back at the University of Delaware, we were using this platform initially, and I thought I had plugged or planned on my car coming in at full charge at 7 o'clock in the morning. And when I jumped in it, took off for Washington, D.C., it was only at 25%. And that was back when we had no charging stations anywhere. So I had to pull into a camp where they charge regular vehicles. So this is, I don't know if this video will play, but it gives you a pretty good idea of. So this is the number of aggregated vehicles using NuV service. So you can see up in the top area the power requested by the power provider, and you can see actively these vehicles in the aggregated mode. So when it asks for more power and tries to pull it back, you can see that it's drawing off of some of the vehicles. Some of the vehicles are not even plugged in or being utilized. So that's basically how it works when you're looking at how it's following the grid, and it depends on which service you're buying and what you're doing with it. But you can track everything on there. Let's see if I can. So this one in this particular case is frequency regulation. This is where they're actually recharging back up again to full capacity. So it's a nice program. You're able to program it, you're able to see it, and take advantage of it. Oops. Let's see if I can escape that. So basically what we're trying to do with the school districts, you find is the total cost of ownership at the beginning of it is $420,000. So it's a big jump from a diesel type truck, which would be $90,000 or $100,000. So what we've been talking to school districts about is looking at total cost of ownership over a 10-year period of time. And with that, we can bring the cost of the vehicle down to parity, basically, with what they pay for. Same with a trash truck. A trash truck right now, if you purchased one, is $640,000 for the whole infrastructure and everything that you need to do a trash truck with. But with the V2G revenues off a trash truck, we can bring it down to what a normal trash truck would sell for, which is about $320,000. So our whole idea is to be able to provide a platform service with our software, and we end up purchasing, in a lot of cases, for the school district, the bus, the EVSE. We give them $20,000 towards the improvement in the infrastructure. The software is for free, and we basically do the interconnect with the grid. And in addition to that, all of the maintenance and warranty for the 10-year period of time is our responsibility. So the school district basically is looking at about somewhere between $2,100 and $2,700 a month for a bus. And again, as I said, we offer the maintenance and service for the length of the contract. So the difference is, we're offering, it varies by geography, because as you all know, you're more familiar with utilities than I am. In certain parts of Illinois, we can't do V2G right now because of the way it's set up. So, but we're still looking, the hot area for us right now is Virginia and the Northeast, also Maryland and Delaware and New Jersey, Pennsylvania. So basically, as I said, we're doing a multi-year contract. We look at service and maintenance that's rolled into it, and we finance the entire package. So we believe that we can provide the lowest cost of ownership and make it easier for school districts to adapt to that. So I appreciate the opportunity to talk a little bit. And if you want to know more, there's my contact information.
Thank you, Dick Johnson. Appreciate it. Great presentation. So we do have some questions from the audience. First one is, why does it take so much, 15 years or so from concept to license?
I'm sorry, from concept to
license.
Good question. I don't know the answer for that. I mean, V2G, what I've found is that the acceptance of electric vehicles is the first hurdle. Then when you throw a what I call voodoo thing like vehicle to grid, where nobody really understands how does that work with utilities, what does that mean for me? When we're selling to school districts, they're only interested in the price of acquisition, not necessarily sharing in the V2G revenues, although we're happy to do that if that's the case. But the technology just took longer to develop with Willett over time, but part of it was just interfacing with the utility and getting their interplay with the whole acceptance of the idea. I don't know if that answers the question, but.
Thank you. Thank you. So final question for you here. So how can we ensure that the life of the battery is not compromised by new platform?
Well, that's a great question. And, I often wondered that when we were first doing V2G. So we had 20 Mini Coopers that were doing vehicle to grid in different locations in Delaware. And that was my concern. But when you look at it, most of the time, and you saw in that presentation, they're not draining the battery. So they're actually working the key part of the battery. They're just exercising the battery. And we found that if you exercise the battery, it has a tendency to last longer. So I can go back and say, okay, we've got 7 vehicles that I converted back almost 12 years now. They've been doing V2G. So if you drove one of the Scion XBs right now, it's about 60% capacity of what it was when we were, so 60 miles rather than 100 miles. So I haven't really noticed that. And there's things set up in our software program so it can't draw too much off of the battery there. But the other thing in the program we're talking about with financing, since we own the vehicle, we're willing to go in if we had to, because occasionally what's going to happen is you will get a bad cell in that vehicle, and we would go in and replace that at no cost. So we're just trying to support the whole EV thing here with the platform.
Thank you. Thank you for answering our audience's questions.
Hi everyone, my name is Quentin Derimo. I'm an associate partner from the Energy and Environment team of SIA Partners in Paris and in charge of our developments in electric mobility. What we wanted to do today, to give you a quick look at what's happening in Europe, what developments that you can have some contrast maybe with what you're experiencing, and showcase a bit of a few of our capabilities. Very quickly, SIA Partners is a 1,800 employee firm with a very large team in the US, and we have a very large energy and environment team, especially in Paris. And we've been dedicating a lot of resource and energy to and so we've really invested in the topic of electric mobility. We have more than 30 consultants who've been very active in this area, and we've added also technological expertise around data science, artificial intelligence, and we've done that across multiple countries: France, of course, US, Canada, Belgium, the Netherlands, the UK, and so on. We publish a lot. And we've developed a number of technologies as well. Basically, so we can support strategic assignments, organization, operations, transformation. We can provide insight. We can support technological development and the development of new services and new offerings. And to give you a few examples of what we've done on the on electric vehicles and electric mobility, we've done the strategic roadmap of a charge point operator, which was the subsidiary of a large French utility. So we basically did everything from the product roadmap to the business plan to the organization, IT roadmap, and so on. We've designed services for power suppliers, utilities to evangelize towards electric vehicles, both on B2B and B2C segments. We've performed a risk review of information systems of a CPO with their systems posing risks on the user experience. We've helped players find materials and vendors for both simple charging and smart charging. We've worked on how to optimize the deployment of EVSEs, of charging infrastructure, and we have a nice tool that I'll show further later to identify the best locations for EVSEs for municipalities. And we're currently working for the French government on policy recommendations to accelerate the deployment of publicly accessible charging infrastructure. What I wanted to share about the major trends on the European market is what is driving the transition. Basically, in Europe, car manufacturers are really pushed by very harsh regulations, what we call CAFE regulations for corporate average fuel economy, that imposes a dramatic fall in the maximum carbon content of each kilometer, to the extent that you cannot meet the target if you don't sell EVs. It's been so far that at some point Volkswagen was said to consider acquiring a car rental company just to secure an outlet for their range of EVs and to ensure that they would meet their CAFE target. So on that, it's really a very powerful incentive to them, and that explains in part why they have EVs in all their segments now. For end users, they're driven by the TCO and the promise of a cheap electric mobility, and that promise has to be met in the future, and we'll see that it's a challenge. A number of subsidies, image, especially for B2B. For business end users, and for other regulations such as low emission areas. For example, it's already the case in other European countries, cities, but Paris will ban diesel fuel vehicles by 2024. And all ICE cars will be banned by 2030,
Hello.
which means we have to be very aggressive in terms of electrification of all fleets.
Hi.
Hi. In terms of progress, of course, across Europe, we see different maturities, and it's been mentioned already by Heather Williams. Norway is, of course, leading the way. They have the largest, the highest penetration of electric vehicles, but other Nordic countries are pretty nice too. And the Netherlands have been a very interesting case to look at, with interesting subsidies and really a movement picking up there. The momentum is picking up everywhere, and for the first time in Q4 2020, EVs passed the diesel cars for sales of new vehicles in France. What we're seeing in terms of hurdles in the near future is, of course, the availability of the infrastructure and secure its connection to the grid. But we've had quite a poor end user experience. We have this partner startup called Happydemics with your partner. We are investors in the company via a startup studio that we have. Happydemics provide survey technologies on very specific and very narrow targets. So we used them as part of the study we're doing for the French government to survey more than 200 drivers of electric vehicles in France to understand what were the irritants for them, what their experience was. And what came out is that it's still very not fluid at all for them, not seamless. More than 2/3 of them need more than one RFID pass to charge on the streets. And they often need like 4 or 5 of them. They basically use whatever pass will work on the infrastructure that they're visiting. Half of the end users still have compatibility issues with old infrastructure and their cables or their vehicles. And the prices are very confusing, and we'll discuss that just later on. And of course, reliability, location, availability have been cited as really key irritants by our respondents. Clearly, if you want people to adopt electric vehicles, you want them to have a seamless experience, something simple, integrated, easy to read and understand. And we're not quite there yet, but we have a few ideas to go down that road. There is also a number of people have said before that that it's like a chicken and an egg conundrum. The point is that there is still a lack of a super solid business model, at least in the near future. You want to promise your end users that the experience is going to be great, that the prices are going to be clear and easy to understand, and that somehow, at the end of the day, it will be cheaper than their old ICE cars. How do you achieve that? And a reliable infrastructure and something easy to use and readable prices when you're asking the private sector to get the infrastructure out there, sometimes several years ahead of the volumes really picking up to achieve their break-even point economically. That's really something that keeps us quite busy, and that's part of the issues we are addressing in the policy recommendations that we're going to make. On the next slide, Khalil, I wanted to show what our end users face on the French market. We did a short benchmark of prices you can find on infrastructure that was deployed by several cities. And so far, the French authorities have fell short of imposing any standard in terms of units for the price, or even of level. So basically, the prices vary from one location to the other. Sometimes it will be charged per duration, per minute, sometimes per consumed energy, sometimes it's going to be a unit charging session. And we've also seen some very small cities or municipalities that have decided that it was costlier for them to try and charge to get a payment for the charging for each charging session. It was costlier than just giving it away for free. So it's really confusing for the end user. And whereas prices should be at some point the result of supply meeting demand, it's today just a cost-based meeting an intention to subsidize the infrastructure. What we see, and I think it's key, and it's more like a personal opinion, it's people keep applying prices in the streets solely on the characteristics of the charger, and they don't take so much into account the end user. And I really believe that there should be a shift in the upcoming years to place the price more on the end user and less on the charge point, because the way you use it has an impact on how much it costs actually. So it's really hard in such a complex environment. It's really hard to incentivize behavior to avoid peak loads and so on. It's complicated for the end user to have a comprehensive view of their budget, and it's hard for the electric mobility service providers, electric mobility operators, to really stand out and provide offers that are readable, that are winning. They tend to have offers that are quite interchangeable and that do not provide enough value for the end user. They're merely a map with a list of points and a means of payment, but they're not necessarily the integrated service or offering that they should be. So that's what we're saying here, and for the end user, it's even quite. It's not very reassuring to see such a variety of prices, because it sends the signal that the market is not super mature, and if you purchase your car, maybe you're going to sell it secondhand in like 6, 7, 8 years. You want to make sure that the infrastructure will still be there. And we've had a few stories on the French market of infrastructure that was phased out because of poor quality or insufficient volumes. And all of those stories have really been dangerous to the development of the electric vehicles in the first place. So what we're looking at is how to secure that, and we're really making recommendations on how to have something that's stable, visible in the long term, and that can provide really stable signals to all the players on the market. Really, that was it for the French for the quick view on the French market. Just maybe on the next slide, Khalil, to expose a little bit more what I was saying on the fact that we might want to shift the approach in terms of how to set the price. We tend today to set the price only on the charger, as if the EV charger is only I mean, it's the same mechanics as a fuel station. You have your fuel station, and there's one price on the fuel station, whatever the end user. But here, you have so many players who want to influence that price. You have the municipality who needs to regulate the use of the public space. You have the charge point operator and their third-party investor who want to maximize profit and traffic and increase loyalty to the charger. And you have the grid who wants to incentivize charging outside of peak hours on the electrical system. And today you have like so many players who sort of collide on the charger. And the resulting price signal is really not clear for the end user. It's not feasible today because the volumes are not there yet, but I'm pretty sure that in 5 years' time, it's very clear that the end user will want the following. They will want something simple, something personalized, with prices and charging offers that are adapted to their mobility patterns. You want cheap prices down your street, around the corner. There is a huge promise and a huge effort around the long-range interoperability, the fact that you can charge wherever you want. And if you're in Paris, you can go down to Spain and be able to charge. It's important to secure the promise, but in the everyday life of the EV motorists, it's going to be quite secondary. Their use is quite routine. They go to work, they commute, they do their groceries, they pick up the kid at school and so on. And they tend to have actually everyday quite stable patterns of behaviors, and there is room for loyalty there, really, and to incentivize loyalty. They will want something that's competitive, and they will want something that's integrated. If someone can provide the nice digital services to navigate that grid, to go from one charger to the other, to anticipate your budget and so on, without having to bother with 4 or 5 RFID cards in your pocket, that's going to be the obvious product that everyone will want. And we believe that there should be sooner or later a change in approach. We can see just a few electric mobility service providers in Europe trying to go down that route. They're still facing hurdles in terms of competition and sometimes price squeezes and so on. But it's really something we're pushing and we're looking at. That was for the European view, and just as part of a little showcase of what we can do, we've prepared a small demo of the. We have a small demo of a tool that we have designed. I'm sorry it's in French because it's even though it's called an EV investment simulator in good French. The demo is in French, but we can very easily adapt it to in English, and I'll try to walk you through it. It serves the need of municipalities who want to optimize where to put what type of charger across the city. We've defined 3 segments of chargers. Basically, L1 will be very slow. We're talking like somewhere between 3 and 7 kilowatts. It's something that will charge your car overnight or while you're at work for several hours, and you're just leaving the car and living your life. L2 will be accelerated charge, talking 22 AC, eventually 24 DC. Is going to charge your battery in a couple of hours while you're grocery shopping, going to the movies, meeting a friend, etc., going to a restaurant. And L3 will be fast charging, so we're talking 50 DC and plus. And what we've designed is we've set up a score to determine a need for each type of charger. We say here for L1 that it's a mix between how many housing do you see in the area and how many offices do you see around. For accelerated charge, it will be housing, offices, and commercial and cultural activities. And here, for fast charging, it will be traffic, mobility hubs, and particular activities. So these are parameters that you fix to calculate, to put a weight on the demand. And what we've done is something that we've rolled out for the city of Brussels here. So this is Brussels in Belgium. We have aggregated a number of data sets. So here I can show you the data sets of the raw data. Basically, for each small area that you can see here, it's pave, each hexagon. We have listed how many housing, how many offices, what is the intensity of commercial activity? Do we see sports facilities, cultural sites? Is there any global? What's the global activity? Is there a lot of traffic in the area? Is there a mobility hub in the vicinity? And what's the population index? You have the basic demographics of the very small area that I showed you. The geographic information in terms of density, number of shops, share of the households living in houses, in apartments, in condos, basically. As you can see here, it's mostly condos in this area, which means you'll need more charging facilities in the streets. And we have even included information about the parking pressure in terms of the rate of occupation of parking spaces between 5 and 7, between 10 and 12, and so on. Once you aggregate those, you can get a score for demand and eventually offer as well of each type of charging infrastructure. And basically, you can help the municipality define a rollout plan. And this tool is currently so here it's just a demo and it's in French, but we could adapt it to whatever context in the US. It's already being used commercially by one of our partner clients. They show it to their municipality clients, and it's part of their offering. So that's something I wanted to show as part of our broader know-how in terms of data science and artificial intelligence as well. That was it for my part. I hope it was clear. And
thank you, Delimo. Thank you, Quentin. We appreciate your presentation. That was great slides and then great demo. David, do you have some couple of questions for the panelists?
Yeah, Khalil, why don't we do this? We have Heather and Dick Johnson and Quentin still with us. And if they could unmute, we've got 3 questions that I've gleaned from chat that seemed relevant. Will increased EV charging be residential, home, or will it be public? How will technological obsolescence of the EV charging infrastructure be addressed? And they say, recall, what we encountered with cell phones and computer. And then, should charging customers be charged for the electricity consumed, the time they're connected to a charger? That kind of goes to the queuing issue, or a combination of both. And if any one of our speakers, Quentin, Heather, or Dick, want to jump in and try to address one of these, we'd be happy to hear from you.
Sure. Well, I can jump in on the first one a little bit. We know that a little over 80% of the current charging is happening for consumers at home. And we know that that is the most cost-effective charging option for customers. So, and primarily driven by the accessibility of being able to charge during low demand times on the grid. And so it stands to reason that that trend will continue, but the only way that we're able to get widespread use of electric vehicles is, of course, to be able to provide long range, charging. So there will be a balance, I believe, between providing an infrastructure for fast charging and public infrastructure. But of course, I believe all EV owners will have continue to have residential charging and use that as their most cost-effective charging option.
So Heather, as you were answering, it kind of struck me that this queuing issue may also kind of fall in there if you're looking at public charging. A thought on that?
Would anyone else like to tackle it first? I'm happy to talk. I just want to give others a chance.
No, you're doing great.
So,
Okay.
yeah, Quentin may have run into some of this also with regard to, SIA Partners studies in Europe with regard to, public infrastructure utilization. The question goes here, you have a car that'll hook up and then sit there for hours, and it doesn't take them that long to charge, and others may want to use that facility. How do we address that issue, if at all?
If I may here, it's really in terms of the unit you would want to use and how you would want to charge it. Basically, what the end users want is always the dollars per kilowatt hour per energy. That's what they want. That's what they understand, because that's what looks more familiar and closer to what happened in their gas tanks. It's true that you might want to combine things with maybe a second charge that would probably be more explicitly dedicated to parking, to the fact that when you are charging, you are using several services. You have the electron, you have the infrastructure, and you have the parking space. You might want to include the minutes for that. It's also important in terms of regulation to clarify what is the status of the parking spot where you put the charger, especially if it's going to be a slow one. Do you consider that it's forbidden charging unless you are an EV? Do you consider that it's a parking place where you have to pay whatever the vehicle you are? And that's also a way of controlling things and avoiding to have people just sticking there and not moving. So what we see is end users want energy. Sometimes you include some minutes as well to deal with the fact that people might stick around otherwise. And finally, for DC charges, especially in France, we tend to do minutes rather than energy, solely for material issues, because the sub-meters that are in the chargers are not, they do not follow a certain European standard that is mandatory. And there is no technology available that is certified to do that. So legally, you cannot charge energy in DC in France without those meters. I hope I wasn't too long.
That was perfect. And Dick Johnson, why don't you take a shot at this last one with regard to technological obsolescence, and then we'll ask Heather and Quentin also to add in.
Yeah, I think one of the critical things that I've been telling people since I've been involved is if you're looking to the future, and even in your home charger, eventually things are going to go, I believe, towards vehicle to grid. So you really want to look at a bidirectional charger. A lot of the people that I've been talking to at school districts and stuff really are putting in a one-way charge, which is fine if that's all you're looking at. But as you can see, we're evolving over time to something more dynamic, which is more of a platform, a digital transformation platform to utilities through vehicles. So if you don't have a bidirectional charger when you're buying it, you're going to be obsolete, I would say, in a couple of years, and you're going to be replacing that charger if that's all you want to do.
Hey, Quentin, I don't know if you want to mention that, we've been working with Nuvve. I think you had mentioned that before. So I don't know if Bob is aware. I'm sorry, Dick is aware.
No, it was mostly through their joint venture with EDF that Richard mentioned on his slides. Dreve.
Dreve, yes.
As for the obsolescence of EV charging, we've discussed with manufacturers of charging infrastructure, with industrials in the likes of Schneider, ABB, and so on. What they would tell us was that they see a gap to secure the ability to have like plug and charge experience with the norm called ISO 15118. That's pretty well identified, and it should come pretty soon. Then there will be smart charging, but other than that, the technology should not. There is not so many risks in terms of obsolescence. There are not so many risks. It's and even for smart charging, I'm not sure that we will need smart charging on 100% of chargers. We will need a good share of those, but not everywhere, probably.
Heather, what's your take on that?
I think we as a planet haven't really done a great job of considering technical obsolescence in general. The problem hasn't been solved. So I'm not sure that EVs, the bar for EVs is very high, but my hope is that planned obsolescence is not part of the EV strategy, much like it is in, say, home appliances where, you need to buy a new washer and dryer every couple of years. And I feel like the hardware manufacturers are really focused on gaining credibility that the appliances that they're selling you will work. And so I feel like that's less of a concern here, but in terms of the planned obsolescence, but over time you can even see the level 1 chargers are already becoming close to obsolete in terms of them the time required for the charges and so forth. So I think it's a really important consideration for the industry as a whole and the planet in general.
Thank you, Heather. And thanks to all our panelists. David, I'll turn it back to you.
Khalil, thank you. I thank SIA Partners again, Shane and Khalil, for sponsoring the program, helping organize the content today. This topic is one that is accelerating. It obviously is a topic that is drawing on global solutions. We saw today we had speakers from Paris, from the Northeast United States, Raleigh, Charlotte, Asheville, North Carolina, out in Southern California, and finally way over out across the Pacific in Hawaii. And all of these technologies are converging in the Carolinas to provide solutions. So we thank everybody who's been with us today. We topped out at a little over 80 participants. We have recorded the session. We will check with our speakers with regard to sharing the PowerPoint decks and also sharing the video. So we thank everyone for being with us. Please check into the E4 Carolinas events page to take a look at the upcoming events, in particular, the next session of the digital technology webinar series that will come up in April. Thank you all. Thanks for being with us.